Hey everyone, welcome to another Fluid Numerics live stream here. I'm Joe Schoonover, of course, from Fluid Numerics, and today we're going to be talking about continuous integration for GPU accelerated Fortran applications using Google's Cloud Build. This is going to build off of what we did last week, where we had just done some basic work on setting up a very simple build pipeline where developers could push to a GitHub repository. And this would automatically trigger a build pipeline that would go through and actually compile the application inside of a Docker container and then do some tests for serial CPU-only applications. And then at the end of this process, if everything passed, what we ended up with was Docker images that were published to the Google Container Registry. Today, we're going to change it up just a little bit. Of course, we're still doing this automated build pipeline, but instead of doing the Docker containers, we're actually going to switch over to Singularity, and I'll explain why that's necessary for what we're doing today in a little bit here. But we will start adding in some tests that can work with single GPU applications. So let's review how we're going to do the build here today. Very similar to what we were doing last week. We're going to start from a Docker container using the Rockham Dev Ubuntu image that's available. We're going to add the GCC 9 dev tool set inside of there, add CUDA toolkit and HipFort. And then of course we've got the application that we're working with today is the Spectra element libraries in Fortran. And then we have other application dependencies. Now, of course, these top three on the list here, that GCC, CUDA toolkit, and HipFort, is a stack that will allow you to build applications if you're using AMD's HIP or you're using OpenMP5 or higher to offload to either AMD or NVIDIA GPUs. So some of the stuff we're going to do today, since we're running on Google Cloud, is all going to be NVIDIA GPUs. At the end of this build process, though, we'll end up with a Singularity image file. Here I've just called it self.sif. Let's talk about how we're going to do the testing. So within Google Cloud Build, what we're actually going to do is add a build step inside of there that's going to reach out to an auto-scaling HPC cluster that's running on Google Cloud. This is called FluidStorm GCP. And essentially what we need to do during this build step is copy that Singularity image file to the cluster. We're going to have to create a script that will go through a process to load Singularity into our path and then execute the Singularity execute some commands inside that Singularity container. And we're going to do this all by just running commands over SSH. In particular, to do the job run, we're going to use Slurm's srun to schedule work on a GPU accelerated node on Google Cloud to run over SSH. And the benefit of doing that is it allows you to actually have exit codes from running your application come right back into Cloud Build, which is really helpful for doing those tests pretty seamlessly. It's very basic. But that's what we're going to do today. So the last bit here, of course, now that we're not doing Docker containers, we can't just add the images block to our Cloud Build file because what we're creating as part of the build process is a Singularity image, not a Docker image. But we can still publish that image somewhere. We can actually put it into a Google Cloud storage container or a storage bucket. And the way you do that is by just using a block that looks like this, where you have artifacts. And then we list out the objects there, so we want the location where we want to push that to. And I'll explain when we get into that file what this looks like here, but essentially it's a Google Cloud Storage bucket. This is the name of a bucket we're using for our application. And then the path is the path of the local file in the Cloud Build environment that we want to push up to the bucket. So let's talk about, again, what we're going to do today, because a lot of what we got to do is really connect a cluster, an HPC cluster, to Cloud Build. So we're going to talk about first how to set up and configure that auto-scaling Slurm cluster on Google Cloud, and then we're going to go through some of the configurations on the Cloud Build side so that you can actually reach out to Compute Engine resources on GCP using the Cloud Build service account, and then we're going to go through some basics of running jobs via Cloud Build. So let me go ahead and just shift my screens here. We're going to head on over to the GCP console. Okay, so that's console.cloud.google.com. The first thing we're going to do is create our HPC cluster. We can do that by going to the Products and Services menu on the top. Click down on Marketplace and look for Fluid Slurm GCP. We're going to use the CentOS solution today. So go ahead and click out on that one, and we'll hit launch. Now I do have one already going here, but I am just walking through this whole setup here so you guys can see how this all gets done. I'm going to just call this deployment CI for continuous integration. And I'm going to put my cluster in US West 1B because this is a zone that actually has the GPUs I want to test on. Highly recommend just take a look at the compute engine documentation if you're unsure of where GPUs are available. Of course, if you want to just use US West 1B, that's fine too. Down here, the login node configuration doesn't matter because after we deploy this, we're actually going to shut off that login node. We're not going to use it. The controller, it's really up to you how big you want to make this. The default values will work fine if you've just got a small team that commits maybe a dozen or so times a day. Of course, the more demands you put on your Slurm controller, the larger you're going to want to make that. Now, the boot disk size on the controller is something you will want to make bigger because this is going to be hosting the home directories, and this is where your Singularity images and all the other artifacts of your build process are going to go. So if your application tests do dump out a lot of files, make sure you have enough space available for that. So I do know my Singularity image file is actually kind of big because it's got all these GPU layers in it. And of course, it's starting from an Ubuntu image, so it comes out to be about 10 gigabytes every time I want to load up that Singularity image file. Of course, it might be good practice just to clean that out of your cluster during the build process at the end. At any rate, I'm going to go ahead and bump this up to 150 just to be safe. And then that first partition, I'm just going to set up a 1 GPU accelerated partition here. And of course, the nice thing about this cluster is if you wanted to test on a variety of GPUs, I'll show you later how you can customize your cluster to allow for more GPUs. So if you want to test on K80s, V100s, P100s, compare performance automatically, all that can be done with this solution. So I'm going to call this, I like to name my partitions after the machine type that's there. So I'm going to call it N1 standard 8, and I'm going to put a P100 GPU on there. The max node count of 10 is just fine. Of course, today I'm not going to be using all that. On the CPU type, I'm going to drop it down to a standard 8. Now, 8 vCPUs is the minimum that you need in order to have 1 GPU attached to your instance, so just keep that in mind. Of course, the more GPUs you add, the more vCPUs you'll want to also add. Again, that's just a requirement on the Google side, and it may even be a requirement for your application. So on the GPUs, we'll click on 1, and I want to put that at a P100. The boot disk size on the compute node really doesn't matter so much unless your application makes use of scratch space or temp directories, things like that are going to be local to that instance. Once we're done, we'll go ahead and hit deploy. What's going to happen here now is Google's deployment manager is going to go through and create a Slurm controller that has the Slurm controller daemon and database daemon installed and ready to go on it, and it's going to create a login node. Now, when that's done, we're actually going to go through the compute engine panel and turn off the login node, and then we're going to hop on the controller and configure the partitions. While this is going on, let's head on over to Cloud Build and set up a few things you need to do there so that your Cloud Build service account can actually reach those instances. So if we go to Cloud Build, down in that Products and Services menu again, this is how you know I'm committing a lot to my repository. I'm getting through my mistakes. Once you're in Cloud Build, we'll go down into Settings. And what you're going to want to do is enable the compute engine service for that service account. If you don't have that enabled, the Cloud Build service will actually fail when we try to connect to the cluster later on in this tutorial. So make sure that's enabled, and then it's going to ask you if you want to also enable service account user when you do that, and you're going to have to answer yes in order for this to work. So make sure that service account user is enabled when we're done, and compute engine is also enabled. Let's head on over to the compute engine page. Now, again, like I said, I actually have another deployment up here, so you'll see some other instances that are currently running, but the ones we need to look at are these guys here, CI login and CI controller. The login we don't need, so you can check that box on it and just hit stop. If you want to delete it, you can delete it as well. That's really up to you. I'm just going to go ahead and stop it for today. And then the next thing we're going to want to do is actually hop into that controller, and we're going to configure the partitions. That's the first step we need to do here. And I want to show you that step in case you wanted to add other GPUs to your cluster for your continuous integration testing. So what I'm going to do is copy that IP address to the clipboard, and up on the top right, I'm going to activate my Cloud Shell and pop that open in a new window. So I close this one while that happens. Okay. When you're here, go ahead and set the project you're working on. So here we'll do gcloud config set project, and then for me it's self fluids. For you, it's going to be whatever GCP project you're working on to build your CI pipeline. I'm going to head into my self Git repository that's locally here. Didn't really need to do that quite yet, but let's go ahead and SSH into that cluster. Now, if you haven't SSH from your Cloud Console before, you'll need to create an SSH key, and then you'll need to add that SSH key to your OS login profile. Check out our series of videos we have on getting started with the Fluid Slurm GCP cluster. We walk through those steps there. All right, so we're on the cluster. If I run sinfo, you see we have one partition. It's the N1 standard 8 P100, and it does have GPUs attached to it. Now, if you did want to add another partition, say you wanted to also test on V100s, I'll show you how to do that real quick. And then the next thing we got to do is figure out what the Linux username is of the service account that's going to be submitting jobs. And the reason why we need to do that is we need to actually add that service account to the Slurm accounting so that that service account can actually submit jobs. So let's go ahead and do that. First, we're going to go ahead and go root and use the cluster services command line tool that comes with all of our solutions to create a cluster config. So that's cluster services list all, and then dump that output to a YAML file. Here I'm calling it config.yaml. Let's go ahead and turn on line numbering. And can I make that text a little bit bigger for you guys? Yes, I can. Perfect. All right, so if we jump down here, basically this file will describe all the details of your cluster, particularly the compute partitions, the Slurm accounts, and the NFS mounts or Lustre mounts or GCS mounts you have on your cluster. The nice thing about this system is you can modify this file, use the cluster services tool to update your cluster on the fly. Today, what we're going to do right now is just add another partition. So what I'm going to do is copy this partition block from line 22 down to 42. Okay, those 20 lines, and paste it below. And let's say on this one we're going to add a V100 GPU, so I'm going to change it to V100. I'll change the name of the machine, and we'll change the name of the partition. Okay, then we can use cluster services update partitions. Okay, and we're going to pass in the config is config.yaml. And of course, if you've seen our tutorials before, I always recommend preview. This would just give you the opportunity to double check the changes you're about to make to your cluster before you make them. If you're happy with that, go ahead and run that same command without the preview flag. Give it a second to update, and then if you run sinfo, bam, we have another partition now with V100s. So this can be helpful if you have applications that have CPU only, some have GPUs, whatever arrangement you want to test on here. You can basically set up multiple partitions, and then for different flavors of your application build, you can target different partitions. Now the next step here is we actually have to figure out how to get the service account added to the Slurm accounting. So we want the cloud build service account to be able to submit jobs. But if I run saccount manager list user, which is the Slurm command to show us what users are there, all I have is root. And now cluster services does provide a tool to add users, and let's show, basically this is going to give us the template of what we need to fill in. So we'll say sample Slurm accounts, and then let's append that to config.yaml. All right, and let's open that back up, hop on down to the bottom, grab the Slurm accounts from 64, paste it down below, and remove those empty brackets. Now the allowed partitions that we want to submit to, let's go ahead and get those. That was, if I run sinfo, the N1 standard 8 P100, and then we'll have the V100 as well. Those are the two partitions we want to be able to submit to. Okay. So get that in there. For the Slurm account name, this is just a name for the group of individuals who will be able to submit to this grouping of partitions. In this case, the an obvious name to choose would be like a CI runner or a continuous integration or something like that. I'm just going to call this CI runners. Okay. And then the users. Now this is where it gets tricky. We need to figure out the Linux username of the service account. So let's take a step back here. What we need to do is hop off the controller. So I'm going to log out. And what we're going to do is create a very simple cloudbuild.yaml file that's going to basically connect to the cluster and just run whoami on the controller. So let's open up our cloudbuild.yaml. Now, if you don't have one already, that's okay. This one right now is what we left off with last week, which just has the stuff from building Docker containers. What I'm actually going to do today is just remove this for now. But remember, what we're going to do here is we need an ID. So the first thing we're going to do is who am I? And we're just doing this temporarily so we can figure out what that service account Linux username is here. The builder that we're going to use is gcr.io cloud builders, and then we're going to use gcloud. Now the entry point though is going to change. Okay, the entry point, what we're going to do is we're going to just call bin/bash, and or let's just do bin/sh. That should be fine. And then for the args, what we want to do for the arguments, as I'm kind of going to need to run a whole series of commands here. So what we need to do is inside of this is establish an SSH connection to the cluster. And the way we're going to do that is, so the first argument is going to be -c for going into bin/sh, and then let's put a whole series of commands here for us. So the first thing we need to do is create a SSH key. This is going to be a temporary SSH key that's created in the cloud build environment. So every time this build step runs, it's a different SSH key. So we'll do trsa -f. We'll go ahead and just save that to temp SSH key. You can put it wherever you want in that cloud build environment, but this is just one recommendation. Okay. So there we go. We've got an SSH key, and then the next thing we actually need to do is run gcloud compute SSH using that SSH key to connect to the controller, and then we're going to issue a command to run over SSH. So we're going to do gcloud compute SSH, and I'm going to use an environment variable. Actually, you know what? Let's just use the name of the controller we have here, and here is just CI controller. Okay. So that's looking good. The next thing we need to do is provide it the zone that controller is in, and that's going to be US West 1B for this controller. I'm going to go ahead and break that line there, and then we need to now pass the SSH key file that we want to use to connect, and that's going to be temp SSH key. All right, and then the command we want to run. All right, so the command is going to be whoami, and what this is going to do is it's going to basically the cloud build service account is going to be executing this. So it's going to actually SSH into the cluster, and it's going to run whoami, which should give us the Linux username for that service account. So let's actually, I'm going to go ahead and just remove my substitutions because I'm not using them, and let's go ahead and run this. Okay, so to run that command manually, of course, you can just do gcloud build submit. So the deal is, once we have this, right, remember what we're doing here is we're going to take that Linux username and we're going to put it in that cluster config so that we can add that service account to the Slurm accounting. Once that service account's in the Slurm accounting, what we'll do next is we'll go through a basic test job to run a Singularity container on that cluster. Okay, so it finished. Okay, so down here you see we got the build, and here's the output from whoami. So that's the service account Linux username. So let's go ahead and hop back in to that into the controller. So I'll do a reverse search for SSH. There we are. Okay, whoops, that's not the right one. That's a different controller. Let me go back to this here. Here's the controller we want. So let's SSH into that guy. It should be CI controller that we want. There it is. So let's go in that config.yaml, hop on down to the bottom, and let's, whoops, of course we need to be root. My bad. Okay, so now let's go ahead and, I had just copied it. All right, so in case you ever lose those build logs, let's go back to that console here. We'll hop into that product service menu and go into cloud build. We'll pull up that last build log and get the service account email from there, or the Linux username from there. So there's our history. There's that last one. And the output is this guy. It starts with SA. So we'll go ahead and copy that. Okay. And paste it in there. Okay, so now that we've got that in there, we can run not G-Cloud, cluster services, update Slurm accounts, config is config.yaml, and then let's preview before we make the change. So what we're gonna do is we're gonna add the user. Here's the Slurm account Linux username. And now if you look back at the home directories, of course, you should see now that that service account also has a home directory because it SSH'd in for the first time. And you can double check that with that user you've just put in there. And then we've got the allowed partitions, N1 standard 8, 1xp100, and v100. So let's make sure that looks good. I think we're good. And the Slurm account name is CI runners. Cool. So let's go ahead and rerun that command, take off that preview flag. Now, at this point, the service account should be able to just run jobs using srun or sbatch over SSH. So let's look at the account manager again. We'll do list user, and there it is. We've got the service account there, and it's in the CI runners account. So let's go ahead and log out. Now the next thing we're going to do is a quick test of doing srun with NVIDIA SMI. What I actually, you know what I should do is hop back in that cluster real fast to show you why I'm using Singularity. So our clusters, that cluster you create in the marketplace comes with SPAC, which is an HPC package manager. If you type SPAC find, it will show you a list of packages that we have actually pre-installed for you using SPAC and using the some configurations that specify like what packages are already available in this cluster. Now you'll notice we have Singularity in here. We like to use Singularity simply because to run Singularity images does not require root escalation on your cluster, particularly if this cluster ends up having multi-purpose for your organization where you have multiple users. This is a good thing. So the deal is, like, if I were to bring SPAC into my, or Singularity into my path, all I need to do is SPAC. Well, let's do this. If I try to run Singularity, it's basically gonna say, hey, the command's not found. But if I do SPAC load Singularity, okay, and then if I run Singularity version, you'll see that, hey, Singularity is actually now in my search path. So the idea is in Cloud Build, what we'll end up doing is creating a Singularity image file in Cloud Build in an isolated environment. We'll copy that Singularity image file up to the cluster and then run our tests on a compute node using Singularity. Well, this is taking a little bit longer today. There we go. Right now, all right, so now I have Singularity in my path. But the basic idea is when we actually go to write our tests, with the knowledge that we're using this cluster, what we need to do is at the top of our test files is basically say, hey, look, we need to load Singularity into our path, and then we need to do a Singularity exec or a Singularity test if you include a test section in that recipe file. Anyways, let's take a look real quick at how to just make sure we can run a job over SSH using Cloud Build. And this is really to convince you that this is working, that we can actually run from Cloud Build on a GPU using this setup. And the reason why I have to show you this is because to actually build our application, it takes about 50 minutes, and I don't want to eat up all your time. So what we need to do today is, so we've already gone through the steps here of what you need to do to connect to the cluster and run a command. So you know you can use the G-Cloud build stepper or the G-Cloud builder, you'll change the entry point to a shell, in this case bin sh, and then we're going to basically do two things. We need to create an SSH key, and then we can use G-Cloud compute SSH to run that command. Now the deal is this command. What we want to do now is imagine you have multiple people on your team. And you actually, we'll handle that in a second. Let's just do something very simple here. What we're going to do is the command we're going to run is srun, which is going to give us a job step in with Slurm. I need to give it the account that I'm running under, so the Slurm account, and that's CI runners, since that's what I configured. If you configured yours differently, of course, you'll use the account you used in that cluster config. In addition to the account, we have the partition that we want to run in, and this is going to be the N1 standard 8 dash 1x P100. Okay. I'm missing a dash here. That's looking good. What else? So we got srun, we got the account, we got the partition. We also need to use gres. So this is a generic resource for Slurm to let the scheduler know that we actually want to use a GPU. So you could say GPU :1. Okay, in this case, since we're just using one GPU. And then the number, let's set the number of tasks. So let's say N1, just do one task. And then what we're going to run is NVIDIA SMI. Okay, so all I've done here is change the command from whoami to srun. And so what you're going to see happen now, when we, provided I didn't make any typos here, let's go ahead and run G-Cloud build submit. And let's do that asynchronously. So I want to just let this run in the background. What's going to happen here is in cloud build, okay, we'll go back to that console. Here's our build. It's right now is loading up that builder, the G-Cloud builder. Once that starts, it's going to go through that process, create the SSH key, and it's going to reach out to run that srun command. Okay, so what we'll do now is, now that that's just sitting there, or just looks like it's sitting there, let's take a look at the compute engine. Okay, now you see we've got this new node that's coming online, the N1 standard 8, 1 by P100. If I click on that, what you'll see is I've got that N1 standard 8 machine, and it's got a P100 GPU on it. Now, if I were to hop into the controller, so again, let's grab that controller IP address. So CI controller, okay. And let's hop into that guy. What you'll see is going on here, if I run SQ, you'll see that the service account has actually submitted a job, and the name of the job is NVIDIA SMI. It's in a configuring state. So what's going on in the background here is this. So if you're not familiar with our solutions, this cluster is an auto-scaling cluster. It's going to create resources on the fly as needed to execute workloads. And that includes now things that hit your Google Cloud build, which is pretty nice. And the cool thing is the output of srun will be dumped to the Google Cloud build logs. Now, if you have to do something with sbatch, that's a little bit more tricky, but this is a really quick way to get started with running larger jobs on GPUs. And you can already imagine, if this all works with Slurm, you can use any of the Slurm commands to run multi-VM, high core count, do your HPC tests at scale, so you can make sure before you ship your code to someone, it's actually going to work. So what we can do is, while this is running, let's talk about the next step that we need to do, and I'll introduce you a little bit more to the Singularity side of this, and then when this is all done, we'll hop back in and I'll show you the build logs to convince you that NVIDIA SMI did work. We should be good to go. So there's two things here I changed from last week. So I changed my project scaffolding just a little bit. So last week, remember, I wrote this like ci.sh file that went through and ran a whole bunch of wrapper unit tests in my application. I moved that into a test subdirectory because I want to start building out tests for different platforms. So I have a script for running serial CPU only, which is that ci.sh. And now I have a ci.gpu.sh, which basically, if you remember from last week, that script is set up to where I have a command line interface for running my unit tests. and I have this flag GPU Excel to set to true. Or of course I can set it to false if I don't want to use GPUs, which is what I'm doing in this serial CPU only case, right? You can see GPU Excel set to false here. But the idea being is, what I want to be able to do when this whole system is set up is have a series of triggers that are set up. One that does a build for GPU, for NVIDIA GPUs, one that does a build for AMD GPUs, one that does serial, one that does MPI only. You kind of get the idea. And I want to be able to just have these scripts already ready to go and have them get installed inside of a container for testing. So in terms of the container, again, I'm using Singularity because Singularity is available on that cluster solution, which makes it a little bit easier. Now, of course, I could build a Docker container and do a Singularity pull. Either way works. But now underneath build, I actually have Docker, Packer, and Singularity. In an upcoming tutorial, we'll talk a little bit more about Packer if you want to create VM images rather than a container. But underneath Singularity, I now have a Singularity recipe file, which does the same thing as that Docker recipe file. It's just different syntax, right? I give it a starting point, and then down below I have my commands to actually install my application. And everything else is, from here, it's basically we got to set up the cloud build file to run through how to do all this. Now, the Singularity build step is a little bit tricky because there's not a default builder allowed or available from Google. However, they do support a community builder. So let's take a look at that. Google Cloud Build Community Builders. Okay. There's a GitHub repository, the Cloud Builders community, where they have a ton of other cloud builders, which are essentially, again, Docker containers that you can execute each of your build steps in. And if you look down below, there is Singularity. So if you wanted to use Singularity, essentially you'll clone this repository, go into that Singularity directory, run a gcloud build submit in here, and then you'll have a Singularity build step available for you. Now I've already done that in mine, but the ID here is we're going to say build Singularity image. Let's say the name. So, oops, forgot a colon already. So the name here is the gcr.io, and then this time the Singularity build step is actually stored in my project, so self-fluids Singularity. Now, once you build yours, it'll be available in your project. And then the next thing we want to do here is just set the args for that. So basically, we're going to be calling Singularity build. So we need build. What do we want to build? The output we want to have is self.sif for Singularity image file. And then the path to the build recipe is the next argument. So we'll say build Singularity self.srf. Okay. So what's going to happen here is this is going to give us these self.sif file. What we're going to need to do to actually test to test that image is we're going to need to come down into our next step here. So let's actually give this a better name. So let's say test Singularity image. Man, if I could spell today. Singularity image GPU. Okay. So what we're going to do first is we are going to actually copy the well, actually, before we copy it, we need to figure out where we're going to copy to. So you might imagine if I had multiple developers in my project pushing to this repository, I don't want the directories where people are running to overlap with each other, right? Otherwise, we could have some issues where one build influences another, and we certainly don't want that. Luckily, there's a built-in environment variable called build ID that we can use to... Let me delete this. We can use that build ID to create a unique directory on the cluster. And then when we run our srun command, what we'll do is, so down here in that srun command, what we'll do is cd into that build ID directory. But before we cd into it, of course, we have to make that directory. So let's copy these two lines here. And let's first run a command over SSH to make that directory. Okay, so that's all we need there. So the first thing we're going to do, right, is we're going to make a directory after the build ID, which is guaranteed to be unique for each build that comes across. The next thing we want to do is SCP, so secure copy, the self.sif file up to the controller, right? So basically once that's there, we'll be able to use that to run Singularity. Whoops, man, all sorts of things. So not just up to the controller in the home directory, we want to put it in that build ID subdirectory. Let me just put that on the next line because that's looking confusing to me. Okay, so we've got, so the first thing we do is we create that build ID, that unique directory. And then what we're doing next is copying that self.sif file up there. And then what we do, whoops, there we are. What we're going to do from there is then execute srun. Now the deal is on the srun side, you're going to need to have another script that kind of wraps around what to do for your individual tests. So I've created this file called test.sh. It has some command line options so that I could specify whether I'm testing a Singularity image, a Docker image, or a GCE VM image. I can toggle on GPUs, yes or no, which is going to control which one of those CI files, whether it's ci.gpu.sh or the ci.sh file that's being run. And then of course the image, and that's just going to be the image name we use. Now today I've just programmed up just the Singularity part of this. So basically after doing some of the command line interface magic up top, which all this is posted on that self repository. I'll make sure I get that link to y'all. But anyways, if the artifact that we're testing is a Singularity artifact, these are the commands we're going to do. So the first one we do is make the SPAC command available in our environment. So we have a little bit of a bug right now on the compute nodes. For some reason, the SPAC package or the SPAC binary is not available in your default search path, but this is how you make it available. So we do source apps SPAC share SPAC setup env.sh, and then we load Singularity. And then if it's a GPU test, then I'm going to do a Singularity exec. The nice thing about Singularity is if you're running on NVIDIA GPUs, you just use the _NV flag, and that will bring in the GPU drivers that are necessary to be able to attach a GPU to that container. If you're testing on AMD systems, you will just use --rocm, ROCM. And then I give it the image name, which for our case is going to be self.sif, and then the command to run inside that container. Now it's very important to recognize here that ci.gpu.sh that I'm showing you here, just be aware that that is a shell script that ends up getting installed inside the container during the build process and made available in the default search path in the container. So it's a lot. If you have any questions on that, feel free to ask them. And then of course, if it's not a GPU, we're just going to run Singularity exec image for the ci.sh. So this kind of gives me a little bit of flexibility. If I have a GPU build, I can call this command with the GPU set to yes. If I have no GPUs, I could set it to no, right? So the idea is, now that I've got that, I actually also need, in addition to copying up that CIF file, I also need to copy up the test.sh file. So let's go ahead and copy that SCP from above. We're going to also copy that guy, test.sh, into that build ID directory, okay? And what else do we need to do? I think that's really it. So now we've got the gcloud compute SSH into the controller. We're going to cd into that build directory, and then we're going to do our srun. And instead of running NVIDIA SMI, okay, I'm actually going to run test.sh, okay? And then let's look at those flags again that I'm going to need. I think I lost my notes here. Give me 1 second. There we are. Okay. Okay, so yeah, the next thing we need to do is we need those flags that we need to pass into that test.sh file. So for me, And again, this is just a particular feature of the testing script that I have here. So we have artifact is singularity, image is self.sif, and then GPU is yes. So the idea is, right, when I run this, basically what's going to happen is this is going to run the build of the singularity image, and then it's going to run the test of the singularity image. And then, of course, I haven't put it in here, but if you remember from the slides I had shown you, we can add the artifacts to publish that self.sif file to our GCS buckets. So that's it for that. Let's do one thing here. I'm going to do a git add of cloudbuild.yaml and make sure I don't got it. I think I don't have any other changes. Yeah, we're good. So if I do a commit, let's say we do switch to singularity for GPU builds and tests. Okay, now if you remember last week, I had set up a build trigger for the develop branch. So as soon as I push this to my develop branch, this will kick off a build for us. And while that's happening, let's hop back over to that cloud build environment. Okay, so here's that trigger that just got kicked off by pushing to that repository. Here's our previous build where we ran NVIDIA SMI, and this was really to convince you that yes, indeed, we are running on GPUs now inside of our build environment. Now, like I said, my actual builds for the Singularity images do take quite a while simply because the images are pretty big. So I don't want to waste your time there, but I hope this gave you an overview of how to connect Google Cloud Build to more resources that are available on Google Cloud platform so that you can do GPU accelerated builds for your application. Now, if you guys have any questions, feel free to reach out to me at support@fluidnumerics.com. Certainly check out our website. That's help.fluidnumerics.com. And yeah, thanks for joining. I guess we'll see you next week. I think next week we're doing VM images. So be sure to tune into that if you think that'd be valuable for your organization. Anyways, thanks again. We'll see you guys next time.